Hey folks, welcome back. So in this video, we will be discussing about what is a CI/CD process, why it is implemented in the first place, and what is a microservice, what is a monolithic service. So we will discuss all of them in this video. So what is a monolithic architecture? Uh, Before the inception of cloud computing, before the inception of the containerization technology, the applications used to be deployed in the monolithic architecture, meaning for example, let's take this vProfile application for instance. This particular application has 5 different components, starting with the load balancer as Nginx, the web server as Tomcat, the queuing as RabbitMQ, caching as Memcache, and then finally the database servers. Finally, the database. So this has around 5 services. In the monolithic architecture, these 5 services will be packed and deployed as a single artifact. And one of the main drawback of this particular architecture is that it is tough to maintain these kind of applications once it is deployed, and the development lifecycle of these monolithic architectures are huge. It also depends upon the size of the application. For example, if you are deploying a large scale business applications, the monolithic application would be very expensive to maintain, and also it takes a lot of work to maintain, deploy, and also if there is any changes to be made, for example, if there is any upgradation of those applications, the entire component and the subcomponent needs to be changed, which is a lot of work basically. And also it is not scalable. It's not easy to scale the monolithic applications. It is not fault tolerant, and it's not cost effective to maintain such applications. So for that reason, since the inception of cloud, what has happened is that much of the applications are containerized in the form of microservices, and they are deployed on the cloud. So let's discuss why the organizations are moving from the native data centers to the cloud service providers. So if a company is trying to maintain their own data centers, there'll be huge capital expenditures and huge operational expenditures. Capital expenditures comes when the company needs to spend a lot of money to purchase those hardwares, and once they are purchased, you need to maintain it, you need to keep upgrading it, you need to maintain it, you need to install those services by yourself. So there's a lot of work, there's a lot of maintenance going on in that particular private data center. That is known as the operational expenditures. And also the scaling, the automation is not at all easy when it comes to the private data centers. So for that reason, much of the organization today are going from the private data centers, the remote data centers, to the cloud. So when they migrate their application workloads to the cloud, what happens is that much of the capital expenditure and operational expenditures reduces, because in most of the in all the cloud service providers, there is a concept known as pay as you go. You pay only for what you use. So that makes them more cost effective, and also it is easy to deploy the infrastructure on the cloud using the console, or in a more effective way, we have something known as the infrastructure as a code. So using the infrastructure as a code, we'll be able to create the infrastructures in the cloud, deploy them, configure them, and destroy them in a couple of minutes, and using the tools like Terraform and so on. And also it is easy to adopt, and if there are multiple systems, where they can be integrated together and run the workload on the cloud. So that's one of the main reasons why organizations are moving towards the cloud. And in the cloud, it is also a provision to run microservices. So what are microservices? So let's take an example of the same application right over here, the vProfile again. So again, this application has 5 different components. In microservice architecture, what's going to happen is that we are going to have something known as a divide and rule concept. So we are going to divide each of these services independently, that is Nginx, Tomcat, RabbitMQ, and so on. So we're going to divide these services independently, and we're going to run these services in the form of containers, and each of these containers will be communicating with each other using the API calls, something like REST API or GPRC APIs, or sometimes HTTP protocol and a messaging buff, and so on. So once these microservices start communicating with each other, it is easy to handle the application workload. So coming to, okay, let's compare these monolithic and microservice architecture. So as you can see on the left side, the monolithic architecture is packed in a single artifact. Thus, it results in it will not be flexible when it comes to upgrading the services, deploying the services, and so on. Whereas on the right side, if you look at these microservice architecture, each of those components will be divided into separate services. So once we divide into those separate services, it is easy to maintain those services. It is easy to spin up those services, and it's also, if something goes wrong, it'll be we can bring those services back in a very less time using multiple container orchestration tool like Kubernetes. So once the containers are back, and if there is any application issues, it will be easy for us to troubleshoot in which component and which node, which we can go up to the container or pod level. So the granularity of the application increases. And also, it is fault tolerant. Basically, fault tolerant means if one of the component of the application goes down, it will not affect the other components, since we can bring up those damaged component in a more faster, in a more quicker way. And the other beauty of microservice is that each microservice can be developed in their own native language. The web application might be developed in PHP or Python. The backend can be developed in MySQL, and so on. And in between, components can be developed in Python, or so on. So microservice supports multiple languages, multiple frameworks, multiple tools, and they can be integrated together. So with the concepts of cloud and with the concepts of microservices in mind, we will come to what CI/CD is. CI/CD is one of the most effective ways of deploying the software into the production environments. Let's discuss what CI means: continuous integration. CD is continuous delivery or continuous deployments. So let's discuss each of them. Coming to continuous integration. So as you can see over here, from step 1 to step 4 is the continuous integration. Continuous integration is the process of fetching the code from a remote repository, let's say GitHub. Once it fetches the code, it is fetched by a CI/CD tool, most popular Jenkins, which is an open source tool for CI/CD operations. Once a Jenkins fetches the code fetches the latest code from the GitHub, it is going to scan the code using the tools like SonarQube or Sonar Cloud to check any vulnerabilities. And once the code is scanned, it is going to compile the code to create the artifacts. And once the artifacts are created, it's going to run some automated tests like the unit tests, the quality tests, the security tests, the load testing, the integration testing, and so on. So after running all these tests, it is that once the artifact goes through these multiple tests, it will be deployed in a registry. The registry might be a JFrog, it might be a Nexus, or if it is a containers, if it's a Docker image, it will be sent to the Docker registry, which is the Docker Hub. So this is the overall view of a continuous integration process, which is a CI process. Coming to the CD. So what is a continuous delivery? Once the application artifact comes and sits in the repository, using the tools like Ansible or the Jenkins itself, it is going to take that artifacts and deploy it into staging area, pre-production area for multiple tests of those applications. That process is known as continuous delivery. Sorry, continuous delivery. Continuous deployment is something similar to delivery. It's just that it requires manual intervention for it to be deployed in the actual production service. Let's say that an artifact is ready from the registry, from the repository. It has gone through all the tests. It has gone through the staging, pre-production area tests, and it requires an approval from the project stakeholders or the business stakeholders. After the approval, that particular artifacts will be deployed in an actual production service. And once it is deployed, that application can be accessed by the end users, so that uh, the downtime will be less. Or and let's come back to the one of the yes, as you can see over here, the continuous integration is testing, building, and pushing the code into the repository, and continuous deployment is taking the artifacts from the repository and going through the staging area, pre-prod and prod environments. Continuous delivery is after the approval from the project stakeholders, it will be deployed onto the production servers. So this is the overall view of a CI/CD process. What are the advantages? If a company employs a CI/CD process in a cloud-based environment, it will be easy for the developers to write and deploy the code, so that it will be easy for the entire team. As soon as a new code is present in the repository, the CI server grabs the code, it's going to run the tests. In case if there is any build failures, it will be passing the alerts to the developers, so that the bugs, or if there is any security checks or vulnerabilities, they will be checked on time, they will be rectified on time, so that it doesn't get carry forward onto the further process that might hamper the actual production value. So that gets fixed in the early on stages. Next, since it is easy to monitor multiple stages of the CI/CD process, in case if there is any build failures, or if there is any testing failures, or if there is any pre-prod or UAT failures, we can get the alerts very easily, so that we can work on it um, in a much higher speed, so that those bugs or issues can be fixed and can be further proceeded for the tests. And once they are done, the deployment of these tested artifacts is much more fast and much more effective. So those are the advantages of the CI/CD pipeline compared to the previous monolithic methodologies. And also, before we end this video, I would like to discuss about the hierarchy in which the CI/CD needs to be implemented and tested. The first is that we need to pick a CI/CD tool, and then we also need to check the code on a regular basis. Let's say that since due to the current demands, due to the current online usages for the any application for that matter, if it's an end-to-end, if it's an E2C, or if it's a B2C or B2B applications, any applications will have multiple user requests. So in order to handle such huge requests, they need to be the application needs to be properly maintained and upgraded on a frequent basis. So for that, the code also needs to be updated regularly, and it needs to be pushed onto the repository. And also, once the code is pushed, the bugs and the other issues needs to be fixed on a priority basis before going to the next step. And then whatever tests we just mentioned, which is the QA tests, or the integration tests, the build tests, load tests, and so on, those test processes can be automated. So once the test processes are automated, those small we can have those artifacts, and we'll have a small deployments and have checkers. So after those small deployments, if it is working, then we can go with the larger scale deployments. So with these effective processes from the bottom to top, we'll have the most effective way of merging the development and the operations processes, and taking the application from the code to the production environment. So this was the overall view of the CI/CD processes, and in the next video we will discuss why Jenkins is used as one of the favorite CI/CD tools. Thank you.